Will it flow or will it blow? So a flowing volcanic eruption would be like in the image where you kind of have a river of lava. It can go many tens of kilometers until it cools and crystallizes into basalt. Or you can have a big eruption and lots of pyroclastic material flying into the atmosphere. It depends on the composition of the lava. So a mafic lava is going to produce these very low viscosity lava flows. The lava is going to come from the vents. It may come from fissure eruptions. It can make lava lakes. This is where we get lava tubes. And you can have huge fountains of lava. In the image here, here's a big glowing fountain of lava. But these are the basalts. Here's a lava pond in here. You get the skin that forms over top of it. It cracks and more lava skin forms and cracks. So these are the low viscosity, low resistance to flow lava flows. Not a lot of silica, so those tetrahedra aren't coming together. It's not trapping gases. Gases are just coming out of the lava as it nears the Earth's surface. The opposite of that would be an explosive eruption. These are the deadly eruptions. Lots of gas is trapped in the viscous lava where all those tetrahedra and the silica are bonding with each other, and so trapping in the heat, the gas, trapping in the gas. And these are going to make big pyroclastic flows. The two kinds of felsic lava, intermediate andesite, and a felsic rhyolite. All right, supervolcanoes. So we can see how the chemistry of the lava dictates how eruptive it is and what's going to be the result of that eruption. Let me move my face. All right, looking at different scales of eruptions. Here on the left, this tower is showing you cubes that represent the cubic miles of ash products of the eruption. So the big one at the bottom is Toba, and then goes Yellowstone, another Yellowstone eruption, Yellowstone, Filigree Fields, Tambora, Crater Lake, Vesuvius, Krakatoa, Pinatubo, Mount St. Helens. So Mount Pinatubo, that's the last big eruption that occurred. That was in 1991. I mentioned it earlier, talking about the products of volcanism with the lahars. So that had a lot of ash and lahar material associated with all the pyroclastic material flying in the sky. In the United States, the last big eruption was Mount St. Helens, which is in the Cascades. So only 0.24 cubic miles of material came out of Mount St. Helens, and from that down, you can see it just gets really big. Oh, hi, Asa. Asa. Yeah. So supervolcanoes would be these ones like Yellowstone, where you implode the volcano because the magma chamber empties out. It's going to collapse on itself, and then you have that huge eruption. That's a supervolcano. So this image here, this figure is showing the cover of ash on the United States, the western United States, after these eruptions. So Mount St. Helens, 1980, was a much smaller eruption. You can see the wind blew the ash across Washington, Idaho, Montana, a little bit, tiny bit of Wyoming. But look at that giant light yellow, the yellow in here, and then the kind of peachy color. Those are both from Yellowstone. Long Valley caldera near Mammoth Lakes here also spewed out, almost 1 million years ago, but a lot of ash. Okay. So here's a little look at Mount St. Helens. Again, it's kind of in your parents' lifetime, my lifetime. I can't figure out where to put my face. This is what it looks like now. So it was a large, majestic stratovolcano. After the eruption, and we're going to talk about it, but it was a little bit of a vertical blast and a lateral blast. So the volcano erupted kind of from the side because of a landslide. So look at the images here. Here's a strato, all those layers. Magma filled up the chamber. It started to bulge out one side. So one of the ways they knew it was going to erupt is because the landform was changing. When it changed, then it changed the relief there, the topography, and then that area collapsed and the lateral blast occurred. Okay, so that is the after effect of what it looks like now. And it blew down trees. They say the destroyed timber was valued at several $100 million. That's crazy. Ash fell all the way over into North Dakota. We didn't see that on that other map, but we'll believe it. There were lahars. 61 people died. Those 61 people were people hunting and fishing, just hanging out in the forest there. There wasn't really a town in the area. So this is what it looks like now. The bottom ring of the crater is still there to the south, but to the north, right, that's where the blast was. So that is the pyroclastic flow. Yeah. The white area is the tree blowdown, all the trees that blew down after that blast. So another eruption is Mount Vesuvius. Lots and lots of volume of ash. Here's the original shape of the volcano, and it's famous and very important in history because of the preservation of this Roman society of Pompeii. And here you can see the excavation, modern suburbs of Naples, and then down 25 meters to the Roman columns here, and then it preserved people kind of in their position when they died. Krakatoa was a big one, 1883. This was a year without a summer. Krakatoa erupted, and when it did, there's a lot of ash material went into the atmosphere and cooled down the earth. As a result of that eruption, there was also a big tsunami that killed 36,000 people were killed. The island, it was like a volcano, and it blew out the volcano. So here's before and after of the shape of it. So red would be before the eruption, and then the gray is what it looks like now. I've included in the PowerPoint presentation, go back and check it out, this link here, this blue Krakatoa, will take you to the Google Earth so you can look at the island, what it looks like now, and you'll see these three islands kind of in a row.